Hello everyone. Previously we had discussed on the nquins 1. So today we'll be solving nquins 2, basically hard problem, right? So this is fine. Now let's get into the question part. So we need to place n queens on an n into n chessboard, right? So we need to place what we need to place n queens on n into n chessboard such that no two queens attack each other, right? Such that no two queens attack each other, not in the same row, column or the diagonal. So we know that how queen moves, right? So if you don't know, queen can move either right, either left, up, down, or the diagonal. uh, Top left, top right, bottom left, and bottom right. This one, any number of this one moves it can take, right? So within the chessboard, so this is fine. uh, any number of steps it can take basically. So it can directly go here, so we don't have up anything. So left it can go here, right up to here, diagonal up to this one, here this one. So here we have only one cell, this is fine, right? So we need to place n queens on an n into n chessboard such that no two queens attack each other, right? So no two queens attack each other. Just give me a second here, let me choose some different this thing. So this is fine. uh, we must return the count of all the distinct solutions. What we need to return? We need to return the count of all the distinct solutions, right? For example, when n equals 4, suppose here if we have n equals 4, so for this example itself, right? So when n equals 4, there are two solutions possible, right? So that's what they have mentioned here. This is solution 1 and this is solution 2, right? See here, uh, we have this one here. So this cannot attack any queen here, right? So this can move either here, here. So this one, right? So this one as well. So this can move here, here, or here. It cannot attack anyone, right? So same goes with this one as well. It can move here, here, straight. So it cannot attack any of this one, right? So final one, this one. Third one we already considered. No, we haven't. So it can move here, here, or here. This one also cannot attack anyone. So this is how we have to display the output. So this is first one. Same goes with second one as well, right? So you can just uh, consider same thing for the second board as well. So this is fine. Now same goes with the example 2. We have n equals 1 and the output is 1, right? So this is fine one. So n equals 4 board we have, they have shown here. So they have given us wonderful examples just for the sake of understanding. Now as we have the understanding of the question, let's do one thing. Let's quickly discuss the this one complexities and then let's write the code one, right? So this is fine. Now first let's go with the approach part. Let's go with the approach part. First what we'll do, we'll place just give me a second here, 1 second man. So I got confused here, right? So yeah, um yep. Let's do one thing. Let's go with the first solution that so let's see how many solutions that we can find first, right? So here in this case, let's see for this one, right? So here first, what let's go with the step by step trace. Let's do one thing. Let's go with the step by step trace. So just listen to this carefully. So after one, after we see this one step by step, I'll be deleting this one, right? So after finishing of one first or the second step, I'll be deleting that one. So just pay attention to this one. So basically before that one, I'll be I want to tell you one thing. We will be going with a backtrack basically, right? So we'll be going with a backtrack. Basically it uses recursion, right? So we'll be going with a backtrack. So first step here would be we'll be trying row 1. So this one I'm speaking of, right? So I'll just write it over here so that we understand clearly, right? So just give me a second here, 1 second. So this one will be q. So we will try first one. So this remains q like this, right? So 4 we have. First we will consider q at the column 0, right? So this is fine. So we are considering at the row 0, right? So we are trying columns left to right. Basically we'll try column equals 0 as well. So this is row 0 column 0 c0. We are placing 0 comma 0 board. Next what we'll do, we'll go with the row 1 with the queen at 0 comma 0, right? So we already have the queen at 0 comma 0. Next step what we'll do, column 0, there will be a column conflict, right? So for the column 1, so main diagonal, this one conflict we cannot place here. First one we cannot place here as well, right? So we can place here the third one, right? So the first queen cannot attack here, right? So third one, right? So now next step what we will do, we'll go with the row 2 with the queens 0 comma 0 and 1 comma 2. So this is nothing but 0 comma 0. We have placed 1 comma 2, another queen at 1 comma 2. So this is nothing but 1 comma 2, right? So this is fine. Now what we will do, we will go with, we'll check whether column 0, so this will be column conflict. Column 1, anti-diagonal conflict, so we cannot place. So for the column 2, again the column conflict, right? So now we can place at the column 3, right? So we cannot place this one column 3 at the column 3 as well. So this will be main diagonal conflict with 1 comma 2. So with this one 1 comma 2, so we cannot place at the column 3 as well, right? So no valid columns in the row 2, right? So in the row 2, so this is not possible at all, right? So now what we will do, again we will backtrack. As I've said, we will be backtracking, right? So again, so we'll place this queue is fine. Now so this queue was the problem, 1 comma 2 here, we this one we considered, right? So that was the problem. So we cannot place here, we cannot place here, we cannot place here. Let's place q here at the end. We can place here as well, right? So now for now let me mark this one as dot, right? So this is fine, this is fine. Now let's do one thing, let's go with the row 2, man. So with 0 comma 0 and 1 comma 3, so let's go with a column equals 0, nothing but here again column conflict with 0 comma 0, so we will skip. So here we can place at the column 1, right? So we can place at the column 1, so this is safe. So let's place at 2 comma 1 basically. So this one I'm speaking of, let's place it over here this time, right? So this step, so we can place over here, this is fine. Now let's move on with the next step, nothing but we have to go with the row 3, right? So column 0 we cannot place, right? So column 0 here, this one, this will be conflict, and column 1 conflict with 2 comma 1, this one will be conflict. And for the column 2, uh, this one, what do we call, diagonal conflict basically, right? So this one 2 comma 1, this itself attacks this one, right? So here also we cannot place, and for the column 4 also we cannot place, this one attacks, right? So this one is not possible, this one is not possible. So no valid columns in the row 3. So again we will backtrack, we will remove 2 comma 1, so we have to remove this part now, right? So now what we will do, we will be let's get back to the, or let's get back at row 2 basically after removing 2 comma 1, right? So we will try c equals 2 and c equals 3, right? So column equals 2, column equals 3. So again we'll be back at row 1 after removing 1 comma 3, no columns will be left there. So we'll backtrack and remove 0 comma 0, right? So let's again we'll come to the first row. So instead of placing q here, so we can go with the next this one, right? So I'll just place, so let me delete this one. I hope till here it was clear, man. So now let me place the q at the second, this one, right? 0 comma 1 basically. So this one will be, let me represent this one by dot itself. We are going step by step, right? So this is fine. Now let's go with the next step. Let's move on with the row 1 with 0 comma 1, right? So column 0 we cannot, column 1 uh, we will be having column conflict, right? So here this one will attack column 0, this is not possible, diagonal conflict. So column 3 also diagonal conflict. So we can go with the column column 0 1 2 3, right? So this is 0, 1 is not possible, 2 is not possible, 3 it is possible. So here we can place, here we can place the queen, right? So this is fine, let me keep dot here as well, 4 into 4 port, right? So this is fine. Now we have placed the queue successfully. Next what we will do, so let's move on with the row 2. So this is row 0, uh, so this is row 1, this is also fine. So this is row 2, this is also fine, and this is row 3. So this is fine. Right, so let's move on with the row 2. So column 0, this is safe. Here itself we can place, right? So here column 0 itself we can place. So this is safe. So here we cannot place, this will attack. So here diagonal conflict. So this one straight, this one itself, the conflict, column conflict, right? So we cannot place it. Column 1, 2, 3, right? So now this is fine. We have placed at 0 itself, say column 0 itself, right? So now we have placed it 2 comma 0 on the board. So this is 2 comma 0, right? 0 comma 0, 1 comma 0, 2 comma 0. So this one, right? So this is fine. We have placed this one at 1 comma 3. We have placed this one at 0 comma 1. So now this is fine. Let's move on with the final one. So now let's come to the row 3 part, right? So column 0 we cannot place this one. What do we call this one? What conflict? Column conflict. So this one also column conflict, right? So this one here also we cannot place. So this one here we can place, right? At this one, what do we call? Row 3. So this one will be 3 comma 0, 3 comma 1, 3 comma 2, right? So we can place this one at the 3 comma 2, right? So here we cannot place this one a column conflict, this one also column conflict, this one also column conflict, right? So we can place here. Now we have successfully found one solution, right? So now r equals 4, nothing but row equals 4, past this one last row, we have found a valid solution. Column, so this one 1, column this one is 3, nothing but, so see here, when I say column, this is 0 comma 1, so we are considering this one column. So this one is 1 comma 3. I'll just name the column here. So this one 3, and this one 0 basically, right? So this one 0, this one nothing but uh, this is nothing but 2 comma 0, right? So I'm just considering column, this one column 2, and this one basically 3 comma 3 comma 0, 3 comma 1, 3 comma 2, right? So this one will be 2 again, 1 comma 3 this one is 0, sorry, 0 column we are considering, right? So basically we have found a valid solution, nothing but columns 1302, 1302, nothing but 0 comma 1, 1 comma 3, 2 comma 0, and finally 3 comma 2, right? So this is one valid solution, this is one valid solution, this one we have considered, right? So this one we have found this one. So I'll leave the second solution to you. You have to find the solution in the same way that I showed for the this one, second solution. Now we will be placing the queen at 3, right? So we have already tried queen, this one placing here and here. So let's we have to try the queen, this one we have to try placing the queen in the third one, third column, right? So column 3 at first, this one 0 comma 3, basically this one will be 0 comma 3. Just try it out in the same way that I showed for the this one first solution, right? So you'll get this solution, right? So just we are making use of the backtrack. Now you are having the idea what we need to do, right? So we'll get the same this one solution. So this is how we got the two output. So basically we'll get one more output, this one, right? This one when I say column, this one will be 0 comma 3, 3 basically 3 1, sorry, 3 0, again this one is 3 3 0, sorry, or 2 0 3 and 1 columns, right? So 2 0 3 and 1 columns, right? So this is one of the solution that we find basically, right? So I got confused, sorry. So this is how we got two solutions. Basically we don't have to return where the queen is present, where we can place the queens. So we just have to return how many solutions that we get basically, right? So we have got two successful solutions, right? For the uh, chessboard, this one 4 into 4 or n equals 4, right? So this one we have to return 2. So the output that we got here is 2, which is equivalent to the output that they have mentioned for the example 1 within the question, right? So yeah, now as we are completely familiar with the approach part, so we are going with the pure backtracking here, right? So as we are completely familiar with the approach part, let's discuss the what do we call complexities quickly. So what will be the time complexity here accordingly with the approach that we discussed? So time complexity would be big of n factorial. So why it is not just big of n, it is n factorial here. So each row tries all the columns with pruning, right? So we will be checking with all the columns. By the end we will be checking all the columns, right? So we'll try everything, we'll backtrack every step if it is not possible. So each row tries all the columns with pruning, so overall time complexity would lead to simple big of n factorial. So this will be the overall time complexity. So what would be the space complexity here? The overall space complexity would be big of n, right? So the overall space complexity would be big of n. So this is for this one column and diagonal tracking arrays. So this is for the column and diagonal tracking arrays. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n factorial and big of n respectively, right? So this is it for the what do we call complexities part. As we are completely familiar with the complexities and the approach part, we are good to write the code. Let's start writing the code. So first step would be we have to go with the arrays just to track whether we have to consider the column left diagonal or the right diagonal that is being occupied, right, or not, basically just to check, right? So first, if column is occupied, right, so I'll just represent this one in this way. Suppose if column is occupied, so I'll just go with column equals new. For that I'll just go with the boolean here, and this is fine. Next, whether main diagonal is occupied, we have to check. Yeah, so I'll just go with boolean. So I should have copy pasted one. Same thing. I would have made the necessary changes. This is fine. Boolean of this one will be 2 and 2. Copy the same thing for the anti-diagonal as well. So we will be going with the main diagonal as well as the anti-diagonal, right? So this one, instead I'll change from d1 to d2, man. So boolean d2, this is fine. New boolean of again 2 into n. So we are done with this part, right? So now let's start backtracking from the row 0, right? So here now uh, to perform this one, to make use of the backtrack, let's make use of the let's go with the helper method backtrack first, and then let's make use of that helper method within the main function or the main method, this one total increments, right? So let's go with the helper method backtrack first. We have to perform backtracking, right, first. So I'll just go with private, and so this one will be backtrack. So let me go with the parameters are row, this one n, and also let me go with the column, nothing but just of the type boolean. So also let me go with the diagonal and main diagonal and the anti-diagonal. So I'll just go with boolean. So this one will be d1 and boolean, so this one will be d2. So this is fine. Yep. Now let's go with the backtrack method. First base case is if all the rows are filled, then we'll be going with a one valid solution, right? So quite obviously, if all the rows are filled, we have only one valid solution, or we can find only one valid solution. So this is nothing but the base case. The second one here, they have shown this one right here, n equals 1, output equals 1. So here I can just write it on this way. So if r equals n, then just let's return 1. This is fine. Now let me go with, or let me initialize count to 0. This is fine. Now let's try placing the queen in each column of current row. So that's what we did, right? So first we placed in 1. So this was not possible actually when I placed. So just give me a second here. When we placed queen here, so this one, so somewhere until row 3 everything was fine. We can place the we were able to place the queens, but row 2 actually, sorry, 0 1 2, we'll start with the 0, right? So here at the row 3 it was impossible to place the queens. It was impossible to place the queen, right? So this one failed. Next we went with this one, queen, placing it the second column. So this was possible. This itself is the solution, right? So this was the first solution. Then we placed the queens. So this I left uh, for you to try, right? So when we place the queen at the column 3, so this is one of the solution that we get basically, right? So this is one of the solution that we get, right? So what I'm trying to say here is we have to we have to try placing queen in each column of the current row. That's what we need to do, right? So as we are going with the backtracking, so we have to articulate the same thing in the form of code. So I'll just go with for and c equals 0. So I'll just go with c less than n. So let me go with c plus plus. So here within the for loop, so we have to check if safe, so if it is safe or not, right? So I mean when I say we are checking if it is safe or not means uh, there should be no conflict in the column or the diagonals, right? So let me go with a simple if condition here. If column of c or d of this one row minus column plus n, this is also fine. So now or so this one will be d2 row plus column, right? So we have to skip, right? So we have to skip if the conflict is present, uh, if we have conflict, sorry, right? So now we have to place the queen and we have to mark that particular column and diagonals as occupied. So that's what we need to do, right? So that's what we did in the approach as well. So I'll just go with, so same thing we have to articulate in the form of code. That's it, right? So column c, let me assign this one. So this one will be diagonal, so this one will be r minus c plus n. So let me assign this one to d2, nothing but anti-diagonal, so this one will be r plus c. So we have to assign this one to boolean value true. Simple, simple, right? So we have to move to the next row. After doing that, we have to move to the, quite obviously, first when we finish off the first row, I mean, when we when we are successful in placing the queen in the first row, we have to move to the next row, quite obviously. So I'll just go with a count here. Count equals count plus. So let me go with a recursion here. Nothing but we have to recurse, right? Basically, I'll be making use of the backtrack here. What are the things that we need to consider here? Row plus one, we have to move to the next row. So and so again, n we have to consider column, so diagonal and anti-diagonal. So this is fine. Now we have to backtrack in the sense we have to remove the queen. In the sense we have to unmark basically, right? So this one I can just write it on this way. Column of c equals this one diagonal. So again I have to write the same thing. So I'll just give me a second here. R minus c plus n. So this one, let me assign this one to um, r plus c. So let me assign this one to the boolean value false. False, right? So this is fine. Finally what we need to do, we shouldn't return the this one where queens are present. Instead we have to return the count, right? So how many valid solutions are present, that we need to return. So in our case, let me go with return count. So we are done with the backtracking. We're done with the backtracking basically. So now let's do one thing. Let's quickly make use of this one. What do we call helper method backtrack within the main function or the main method. So I'll just go with main method in the sense total queens. So this one I'm speaking of, right? So let me paste it over here. Backtrack. So what are the parameters? We have to backtrack from the row 0, right? So from the row 0 we have to backtrack. We have to start backtracking from here, right? So this one basically where I have placed the cursor actually, right? So here we have to backtrack from the row 0. So I'll just go with a 0 and we need n. Also we have to go with the column, diagonal as well as the anti-diagonal. Simple. So this is it for the code, right? So let me format the code once and let me hit the run button. I hope this works, man. Let's see what happened here. Line number 18. So what error we have got here? Cannot find the variable. So this has to be d1, main diagonal basically. I have given only d. So yeah, now this has to work. Let's see. Yeah, you can clearly see here the sample test cases are getting passed, right? So let me hit the submit button. I hope this works for all the test cases, man. Let's see. So you can clearly see here all the test cases are getting past. Means the code works absolutely correct in this case, right? So I hope whatever the code that I have written, I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.